Hello students, good morning and welcome to the new lecture of physics. This is our third lecture on unit and measurement. If you remember, in last two lectures we have discussed about different types of unit system, how they came into existence. We have discussed about first four unit system, that was FPS, that is British unit system, where F is for foot, pound for P for pound and S for second. Then we have discussed about CGS and MKS, centimeter, gram, second, that is measurement for length, mass and time. And MKS is meter, kilogram and second, units for length, mass and time. And then we have discussed about MKSA, right? Meter, kilogram, second, and A is for electric current, ampere, right? But these quantities were not enough, these units were not enough for measuring all the physical quantities, all the remaining physical quantities. So in 1971, right? In 1971, a conference was held in France on units and measurement, right? That was measurement and weights. In that conference, scientists throughout the world had decided the minimum number of physical quantities, and those physical quantities were given name as fundamental physical quantities or base quantities. Right? Their units were known as fundamental units or base unit, and the seven quantities combined together were given name as SI unit system. So there were seven physical quantities in SI unit system. Their names, their units, their symbol, everything was decided in that conference. After that, we have discussed the practical norms for using SI unit system, right? In fact, we have discussed 5 different types of norms for using SI unit system. Before that, just quickly revise those 7 physical quantities which are present in SI unit system. The first one is length. Its unit is meter and symbol is m. The second one was mass, kilogram unit, and symbol was kg. The third one is time. Symbol is S and unit is second. The fourth one is electric current. Unit is ampere and symbol is A. Fifth one is luminous intensity, or in that case we have written, I think, fifth one as thermodynamic temperature. Unit is Kelvin and symbol is capital K. Then we have sixth one is luminous intensity. Candela is its unit and symbol is CD. And the last one was amount of substance, amount of matter, you can say. Unit is mole and symbol is MOL. And the practical norms for using this SI system was, the first one was, the symbol should be written as it is given in the table. Right? We should use this symbol as it is given in the table. The second one was, there should not be any full stop in between or at the end of the symbol of a given unit. Third one was, unit should always be in a singular form. Right? Fourth one was, if the unit is named after the name of a scientist, then the whole unit should be written with capital letter, a small letter, and the symbol will always be a capital letter. Suppose ampere, so if you want to write ampere, you will start with AMPERE, where A will be a small letter. But if you want to write symbol, it's capital A for ampere. Right? And the last one was, unit should always be in a single ratio. Ratio of ratio is not allowed. So these were the 5 norms for using SI unit system. Now in this lecture, we are going to discuss about supplementary units. But before supplementary units, in last lecture, we have also discussed about derived quantities and derived units. Right? So what are supplementary units or supplementary quantities? Basically, there are two supplementary units which we are going to discuss. The number one is plane angle. Right? So supplementary units. Chapter 2, unit and measurement. And in that, supplementary unit. Now in supplementary unit, we have first one as plane angle. Now this plane angle is represented by theta, or you can write delta theta if you want, right? D theta. So these are all symbol for plane angle. We are going to write theta only. So for plane angle, symbol will be theta. It is defined as the ratio of arc to the radius, right? Ratio of arc to the radius. So you can say that plane angle theta is defined as arc over radius. Now arc over radius means, suppose if you have come across this in standard pen. Suppose if this is the arc of a curvature or a circle, right? And this is the center of that circle. Then from this point you can say that this will be the radius of the circular path. Right? This will be radius. And this AB, this portion of AB will be our arc. And this angle is theta. Right? So here theta is defined as arc upon radius, or arc equal to angle into radius, right? So angle theta, plane angle theta is arc upon radius. Now if you see, arc is a length, right? And radius is also a length. So if you write unit, then meter over meter will get cancelled out. It means that it is having no such SI unit, you can say. But to identify that the given quantity is an angle, we are writing degree, right? Minute, second. Now here, since the ratio is unitless, supplementary unit was provided for plane angle, right? A supplementary unit was given to it, and it is known as supplementary unit. So the supplementary unit for plane angle was radian, or is radian, right? And it is written as RAD. So plane angle is defined as arc over radius, and its unit is radian, written as RAD, right? So in physics, for us, we will write angle in radian only. Most probably we are going to come across angles in radian. Say for example, if angle is given as 30 degree, then it is necessary for us to convert it into radian. So after this topic, we are going to discuss how we will convert degree into radian, minute into radian, or second into radian. Right? The next supplementary unit is solid angle. And the symbol for this is omega. Right? This is its symbol. So solid angle is defined as area over radius square. Square of radius. Now which kind of area? It is intercepted area of a sphere. If you consider a sphere and if you cut a sphere, you will get a small curved surface, right? So that area of that curved surface is known as intercepted area. Let us say if we want to draw, let us say this is the curved part of any sphere which we have cut, right? And this is the apex O. It is the center of that sphere, imaginary sphere. So the angle here formed is known as solid angle, and this will be our intercepted area. And this part, this distance from the surface is our radius of the curve part, right? So that intercepted area over square of radius is known as solid angle. Now unit of area is again meter square. Radius will be in meters, so meter square will be meter square, right? So meter square over meter square, again solid angle will be a unitless quantity. So to identify that the given physical quantity is for solid angle, we have given a supplementary unit to it. And the unit for solid angle is steradian. The unit for supplementary angle is steradian. So the unit of solid angle is steradian, and it is written as SR for steradian. Right? Now what is solid angle? Again we will define solid angle as, it is defined as the ratio of intercepted area of a given solid sphere. Intercepted area of a sphere. Right? The ratio of the intercepted area of the sphere taken about the point O, which is apex, or you can say that the center of the sphere, to the radius of the sphere, square of radius of the sphere. So area upon radius square. This is solid angle, right? So unit of solid angle is supplementary unit of solid angle is steradian, and its symbol is SR. So these are the two supplementary units which are given in our NCERT textbook. Now we are going to discuss about how to convert degree into radian, or let us say minute into radian and second into radian. So let us say you must be knowing this, that 180 degree is pi radian. 180 degrees is equal to pi radian. You are writing something. You might come across 90 degree which you are writing as pi, by 2, right? So 90 degrees pi by 2. So if you multiply 2 on the other side, you will get 180 degree is equal to pi radian. So 180 degree is equal to pi radian. Now divide this equation by 180. Dividing both the side by 180, what you will get? 180 degree over 180 will be equal to pi over 180 radian. So here 180 will get cancelled out. So 1 degree will be equal to pi by 180 radian. This will be the answer. To convert degree into radian, you have to multiply it by pi by 180. Right? Now the second case is to convert minute into radian. So we have formula 1 degree equal to pi by 180 radian. But you must know that 1 degree is actually 60 minute. 1 degree is 60 minute. So therefore you can say that 1 degree, which is equal to 60 minute, is equal to pi by 180 radian. Now again we will divide both the side by 60 so that we can get 1 minute. So therefore 60 minute over 60 will be equal to pi over 180 into 60. So this 60 will get cancelled out. So therefore we will get 1 minute equal to pi by 180 into 60 radian. 1 minute is pi by 180 into 60 radian. Remember, you have to prepare all these things, because while solving example, you will have to convert, or you should convert degree into radian or minute into radian. It will be necessary for us to convert degree into radian. So you should know this concept, right? You should prepare this. Now the third one is for second, right? 1 minute is given as pi by 180 into 60 radian, right? But again, 1 minute is equal to 60 seconds. Remember, for second we will write 2 such dash over here, and for minute 1 only. So therefore 60 seconds will be pi by 180 into 60 radian. Again we are going to divide by 60 on both the sides. So 60 seconds over 60 will be equal to pi over 180 into 60 radian. So 60 will get cancelled out. So you can say that 1 second will be equal to pi over 180 into 60 radian. So if you want to convert second into radian, you will multiply that quantity with pi by 180 into 3600. 60 into 60 will be 3600. So you can say that if you want to convert 1 second into radian, then the answer will be pi, that quantity, into pi divided by 180 into 3600. Clear? So this is how we are going to convert degree, minute or second into radian. Now let us solve few example based on conversion of degree into radian, minute into radian. So 3-4 example here we will solve how you can convert a given degree or minute or second into radian. Now let us solve few example in which we will convert degree into radian, minute into radian, second into radian, as well as combination of degree and minute, or minute and second into radian. Let us start with some simple example. Suppose we want to convert 5 degree into radian. So convert 5 degree into radian. So we know that 5 degree, we know that 1 degree is pi by 180 radian, right? 1 degree is pi by 180 degrees. So if you multiply 5 on both the sides, so therefore you get 5 degree will be equal to 5 into pi by 180 degree. So this will be equal to, you can easily simplify using calculator and all that. So if we use calculator over here, so 5 into 3.14, value of pi is 3.14. So 5 into 3.14 divided by 180. 5 into 3.14 divided by 180 will be 0.08722. 0.08722 radian. This will be the answer of 5 degree into radian. This is how we can convert 5 degree into radian. Let us take another simple example in which we will convert minute into radian. Let us say, second example, we want to convert 12 minute into radian. Convert 12 minute into radian. Convert 12 minute into radian. So again, we know that 1 minute equal to, we know that 1 minute will be equal to pi by 180 into 60. So again, if you multiply 12 on both the sides, so you get 12 minute equal to 12 into pi by 180 into 60. Right? So 12 into pi into pi, instead of pi we write 3.14. So 12 into 3.14, 12 into 3.14 divided by 180 divided by 60. So 0.003488. This is radian. So this will be equal to 0.003488 radian, right? So this is how we can convert minute into radian. Remember, instead of pi, if you want, you can take 22 by 7 also, right? But 22 by 7 will be nearly 3.14, so we can directly write 3.14. Now let us take another example in which we will convert second into radian. Let us say we have 38 second. Convert 38 second into radian. Convert 38 second into radian. So again, we know that 1 second is pi by 180 into 60 into 60, right? So again, 38 means you will multiply 38. So 38 minute second will be equal to 38 into, instead of pi we can write 3.14 divided by 180 into 60 into 60 is 3600. So here 38 into 3.14. 38 into 3.14 divided by 180 divided by 3600, 0.0001841. So this will be equal to 0.0001841 radian. So this is how we can convert degree, minute or second into radian. Now let us take an example in which we have combination of degree and radian. Degree and minute. So for example, example number 4, convert 3 degree 12 minute into radian. So obviously what you will do, or what majority of students do, is they will convert 3 degree separately into radian and 12 minutes separately into radian. So you can say that 3 degree 12 minute will be equal to 1 degree is pi by 180 radian. So 3 into pi by 180 plus 12 into, this is in minutes, so for minute pi by 180 into 60, and this you can simplify, right? So this will be equal to, let us say pi by 180 will take common, so pi by 180 common. So in bracket 3 plus 12 by 60, right? So if you cross multiply this, you will get 12 ones are 12, 12 5s are. So this will be equal to pi by 180 into 3 plus 1 by 5. So 5 is 15 plus 1 16 by 5. Therefore 3 degree 12 minute will be equal to pi by 180, and 3 5s are 15 plus 1 is 16. 3 5s are 15 plus 1 is 16. So into 16 over 5. So if you simplify this, right, we will get pi divided by 180. 3.14 divided by 180 into 16 divided by 5. 0.0558. The answer will be 0.055822, something like that, right? Radian. So the answer will be 0.055822 and so on, right? Radian. This will be the conversion for 3 degree 12 minute into radian. But of course, instead of that, we can use another method. Generally, we are going to use this method only, what we are going to discuss now. What we have to do is, we have 3 degree 12 minute. Suppose if I will give you, let us say 5 rupees 30 paisa, then how will convert that into same unit? So you can say that 5 rupees is 500 paisa plus 30 paisa. So that will equal to 530 paisa. So this is how we are going to convert into same unit. Degree and minute is there, right? So either you convert minute into degree or degree into minute and make a same unit for both these quantities, right? So you have 3 degree 12 minute. So you can say that this is equal to 3 into 60 minute, because 1 degree is 60 minute, right? Plus 12 minute. So this will be equal to 6 3s are 18. 180 minute plus 12 minute. So that will be equal to 192 minute. So this will be equal to 192 into pi by 180 into 60 radian. So if you multiply 192 into pi, that is 192 into 3.14 divided by 180 divided by 60. The answer will be same, 0.0558. This will equal to 0.055822 radian, right? So either you can use this method or you can use this method. Obviously this is simple one, right? So this method we are going to use while solving examples. Yeah, obviously you can use this also if you want, but I think that will be easier one and the simplest one. So generally we will prefer this method for solving this kind of examples. Now I will give you a few examples for your practice, right? Let us say something around 5 examples for your practice which you will solve yourself. So the 6th one is convert 1 degree 54 minute into radian. 7th, convert, let us say 20 minute 38 seconds into radian. 8, convert 4 degree 20 seconds into radian. 9th one, convert 7 degree 10 minute and 40 seconds into radian. And the last one, convert 12 degree 12 minute and 12 second into radian. Right, so these are the 5 examples which you have to solve yourself. We have already discussed how we can convert degree into radian, minute into radian, or second into radian, or combination of all these. So I think this will be easier for you to solve. Now let us consider example 2.1 of our textbook. In example 2.1, in example 2.1 it is given that convert convert A 1 degree, B 1 minute, and C 1 second into radian. So it is given that convert 1 degree, 1 minute and 1 second into radian. Now we have already solved this kind of example, right, in which we have calculated the value of 1 degree, 1 minute and 1 radian. So similar kind of example is that convert 1 degree, 1 minute and 1 second into radian. But it is given that use 360 degree equal to 2 pi radian and 1 degree equal to 60 minute and 60 minute is equal to, 1 minute equal to 60 seconds. So this condition is given. So here let us start with A. First one, we have to convert 1 degree into radian. We have to convert 1 degree into radian. So we know that it is given 360 degree is equal to 2 pi radian. So therefore, if you divide both the side by 360 degree, so 360 degree over 360 degree, so 360 will be equal to 2 pi over 360. We are dividing both the side by 360. So this will get cancelled out and we will get therefore 1 degree will be equal to 2 pi over 360 radian. So if you cancel 2, 180, so you can say that this is pi by 180 radian. Now the value of pi is 3.14, right? So if you divide 3.14, so here 3.14 divided by 180 will be equal to 0.01744 radian. This is for 1 degree. Now for B, it is given 1 degree equal to 60 minutes, right? So therefore 1 minute will be equal to 1 by 60 degree, you can say, right? 1 minute will be equal to 1 by 60 degree. What we have done, we have divided by 60 on both the sides. Now the value of 1 degree is already calculated, right? So if you want to convert this degree into radian, you have to simply multiply by this. So this will be equal to 1 by 60 into 0.01744 radian. So if you divide 0.01744 divided by 60, you will get 0.0002906 radian. Now if you want to convert this into power, right? So if you move 2 points over here, 1, 2, you can write this as, this is equal to 1.744 into 10 to the power minus 2 radian. We have shifted 2 points on the right hand side. Remember, if you shift 2 points on the right hand side, you have to take power negative, right? So in the same way, here we are going to shift 1, 2, 3, 4 points. You can check 1, 2, 3, 4. So you can write this as 2.906 into 10 to the power minus 4 radian. If you are shifting the points towards right hand side, you have to increase power by minus, right? Negative. The power will become negative, you can see. Now in the third case, we have to convert 1 second into radian. So the given condition is 1 minute equal to 60 seconds. So if you divide by 60 on both the sides, you will get therefore 1 by 60 minute will be equal to 60 by 60. So we can cancel, so you get 1 second. So therefore we got 1 second equal to 1 by 60. So therefore we can say that therefore 1 second will be equal to 1 by 60 minute. So therefore 1 second will be equal to, now 1 by 60 minute, right? So you can say that 1 by 60, and to convert minute into radian we have 2.906 into 10 to the power minus 4 radian. So 2.906 906 divided by 60, will get 4.8433 into 10 to the power minus 6 radian. So this is how we can convert minute, degree or second into radian. Clear? Now let us consider another very simple example from our textbook. That is unsolved example 2.1, or you can say that exercise 2.1. It is given that fill in the blanks in which first one, that is A1, is fill in the blanks in that first one is the volume of cube of side 1 centimeter is equal to volume of a cube of side 1 centimeter is equal to blank meter cube. So the volume of cube of side 1 centimeter is equal to blank meter cube. We have to find volume in meter cube. Volume is length is given in centimeter. So we know that volume of a cube is V is equal to L cube, right? So here 1 cube, so therefore you can say that 1 centimeter cube. So volume will be 1 centimeter cube, but we want answer in meter cube. So also you must be knowing that 1 meter is 100 centimeter. 1 meter is 100 centimeter. So 1 centimeter will be 10 raised to minus 2 meter. So therefore we can say that V will be equal to 1 centimeter is 1 into 10 raised to minus 2 meter whole cube. Right. So 2 3s are 6. So this will be equal to 10 raised to minus 6 meter cube. 1 into something will be that number only. So 10 raised to minus 2 cube. So 2 3s are 6. So 10 raised to minus 6 meter cube. Power of power will always be multiplied. So 2 3s are 6. 10 raised to minus 6 meter cube. This will be our answer. So the volume of a cube of side 1 centimeter is equal to 10 to the power minus 6 meter cube. Now the second one is B. We have to find the surface area of a solid cylinder. So surface area of a solid cylinder. Surface area of a solid cylinder of radius. Surface area of a solid cylinder of radius 2 cm and height 10 cm of radius 2 cm and height 10 cm is equal to blank mm square. Now here length, that is height and radius, is given in centimeter and we have to find area in millimeter square, right? So area of cylinder, we know that the surface area of a solid cylinder is, formula for area is A is equal to 2 pi r into r plus h. Remember, we want here area in mm square, millimeter square, and the given data is in centimeter. So here radius is given as 2 centimeter. Remember, 1 centimeter is 10 mm. 1 centimeter equal to 10 mm. So this will be equal to 2 into 10 mm. So you can directly write 20 mm. Right. In the same way, height is given as 10 centimeter. So that is 10 into 10 mm. We can say that 100 This conversion you should know how you can convert kg into gram, gram into kg, centimeter into meter, meter into mm, right, millimeter, and so on. So this is the conversion for that. So radius we are knowing, height we are knowing, so we can easily calculate the area. So therefore, from equation 1, you can say that area A will be equal to 2 into pi is 3.14 into radius is 20 into 20 plus 100. So 2 into 3.14 will be 6.28 into 20 into 120. 100 plus 20 will be 120. Right? 100 plus 20 will be 120. So 120 into 20 into 6.28 will be equal to 15072. This will be equal to 15072 mm square. Of course, you can stop here, but if the standard form is you have to write this as 1.5. Now check if this is the answer, then we can say that your decimal point is there. You are moving this decimal point here 1, 2, 3, 4. So you can say that 1.5072 into 10 to the power minus 4. Sorry, plus 4. If you are moving on the left hand side, power will be positive, and if you are moving on the right hand side, power will be negative. So 1.5072 into 10 raised to 4 mm square. Remember, you can stop here also, but this is the standard way of writing, so we will write this answer. So our answer will be 1.5 into 10 raised to 4 mm square. If you want, you can write 1.5 into 10 raised to 4 mm square. Right. Now in 2.1, C, that is the third one, is a vehicle is going with a speed of 18 km per hour. A vehicle is moving with a speed of 18 km per hour. So we have a vehicle which is moving at a speed of 18 km per hour, covers blank meter in 1 second. Covers blank meter in 1 second. That is, we have to find the distance covered by the vehicle in 1 second. So here given is speed of vehicle 18 km per hour. Now kilometer, 1 kilometer means 1000 meters, so you can write 1000 meter. Remember, 1 kilometer is 1000 meter, and 1 hour is 3600 second. 1 hour is 3600 second. So you can see 0000 will get cancelled. 2 5s are 10, 2 18s are 36. So this will be equal to 18 into 5 by 18 meter per second. So it means that if you want to convert kilometer per hour into meter per second, if we want to convert kilometer per hour into meter per second, we have to multiply it by 5 by 18. So here you can see that 18 will get cancelled out. So therefore speed will be, therefore you can say that therefore V will be equal to 5 meter per second. The speed of vehicle will be 5 meter per second. It means that it will cover 5 meter in 1 second. 5 meter per second. So you can say that a vehicle is moving with a speed of 18 km per hour, covers 5 meter in 1 second. If it is asked that the distance covered by vehicle in 2 seconds, so 5 meter per second means 5 meter in 1 second. So in 2 seconds it will be 10 meter. In 3 seconds it will be 15 meter, and so on.